I'm Martin Mayo. I like to call myself a co-founder, although MyGet is only my side job and not my main job. I do a lot of stuff related to Windows Azure and the Azure user group as well. I blog on all those things, and I've been building MyGet together with a former colleague of mine. What I will do is give you a quick introduction on what is NuGet, what is MyGet, how we started, what we did not know at that time, and that we would have liked to know at that time when we started. We'll see that we went through a lot of architectural changes along the way, so we are now in our second architecture. I'll also give you a pointer about Azure Access Control Service, because still I think a lot of people are not using it, and it's an awesome product really, and I hope it will be there forever. We've also had some tough times, and as I like to call them, those are learning moments. But seriously, those were really tough times where we had a major downtime, and it was risky. Fuck-ups. Yes, fuck-ups. So, NuGet and MyGet. Who does not know NuGet? Feel free to admit, no problem. Okay. NuGet is a way of adding software dependencies to your project. So what we're doing is build something for developers. NuGet is not built by us, it's built by Microsoft. And Microsoft has been pushing it to basically find all your dependencies that you want to have in your project. So for example, if you're willing to install Elma into your project, you can just search it, install it. If there's an update available, you can click the update button, and it references the assemblies, it adds updates to configuration, all those things like that. Now, what happens if you want to basically build your own feed containing packages? Because this thing, by default, uses a Microsoft feed which contains every open source project out there that is publishing a package. But what if you have your internal framework that you want to publish? You probably don't want it to be in this list for every developer out there. So one solution to that may be using MyGet, which is our product. And we allow you to work with dependency management in NuGet on private feeds. We have user management, we have permissions, so you can have people who can only read packages but not write packages. We have a workflow where you can have a development feed and then upload something to a production feed or a release feed. We even do builds. So if you have an open source project out there or something on GitHub or Bitbucket or Codeplex, you can just click the button and we will generate a package for you. By convention, it doesn't work for every project, but we try our best and create a package for that source code. So that's MyGet in a very short way. What else do we do? Well, you can store your intellectual property safely with us. So if you want to store your own NuGet packages on a feed at MyGet, we can do that. If you want to create packages but you don't know how, well, we have build services and we will create a package for you. We have security, we have read-only, we have write-only, we have community feeds where you can have basically every user who puts a package on that feed owns that package, but he cannot do anything with other packages. We have activity streams, so you can also see which user did what, when did a package get added to a feed, things like that. We have a symbol server, so if you push a package to MyGet and you start debugging in Visual Studio and you add our symbol server, what you will see is that you can debug into the assemblies and into the symbols downloaded from the symbol server in one go. And we also have analytics, so you can see which package depends on which other package, depends on which other package, how many downloads did we have for a certain package. So really a lot of features in making your life easier using NuGet. So how we started? We didn't really start with the idea of building a startup around this thing. The real beginning of MyGet was this one. I did a blog post back in May 2011. Which was using dynamic WCF service routes. So the main idea there was, if I have WCF and I host it in HTTP and IIS, can I use ASP.NET routing to have multiple URLs pointing to the same service but with different route parameters that I can use in the service? That was the real beginning, but we didn't know that back then. Then NuPack came around, which was the first name of NuGet. I don't know why they ditched it, but I think NuGet is quite better in talking about it. But anyway, NuPack was using OData as their feed, so they had packages on a feed, and they were using OData for that. And since OData at that time, in that incarnation of the framework, Astoria back then, was using WCF, well, why not combine it with the blog post I did previously and create multiple feeds, multiple OData feeds for NewPack in a service? So that's what we did. Together with Xavier, my colleague, we were basically talking about ideas, and then during tech days there were some sessions that we didn't want to follow, so we decided, let's start coding. And a couple of days later, we did this blog post and we had our prototype online. So we had a basic prototype online, only allowing you to basically create your list of favorite packages. You couldn't upload packages, you could just select packages from the official NuGet feed and create your own smaller subset with favorite packages from that one. Which was pretty cool, and we used a lot of technologies in there. Windows Azure, because it was new at the time, we decided, let's go for Azure. We have an MSDN account, it's free, so let's go Azure, yay. We also decided to use stable storage and blob storage for all our storage needs, so both just storing packages as well as storing metadata about those packages, as storing feeds and things like that. And we chose it, first of all, because it was really cheap. I mean, 1 cent at the time per gigabyte per month, it's nothing. And we didn't even have a gigabyte in data back then, so it was really cheap. Another reason for this is, well, everybody's talking about NoSQL back then. And we were like, okay, table storage, Microsoft sells it as NoSQL, we'll do NoSQL. So that's another reason why we chose table storage there. We also chose Windows Azure ACS, and not because of the reasons we are using it today, but mainly because we didn't want to write yet another user registration system. Everyone, I think, who hasn't written a user registration system in their career? No one? Seriously? So that's the reason why we decided to go with ACS and use all those social logins available. ASP.NET MVC 2 back then, and also Managed Extensibility Framework, basically for doing all our dependency injection needs. Did we use any best practices in our codes? Well, that's the answer. Not really. Not to say no, actually. So back then, we had one web role, one storage account, and we were doing everything in there. We were, I think we had 1 or 2 controllers in MVC containing 2 or 3 or 4 action methods, and they were all connecting to table storage directly. So no repositories, no whatever services in there, just access table storage directly. Why? Because we didn't, at this time, think we would make any money about it, out of it. It was still just a prototype, still a proof of concept, still something we wanted to test. Now, what we did not know is that users would come. So we started with 5 or 10 feeds, and people were like, well, we were looking at who owned those feeds, and it was all the closed community. I saw Yves create a feed, I saw Panos create a feed, Xavier and I created a feed, so that's 4 out of our 5 users. And then we grew to 70 feeds, which was quite a number back then, because we didn't even envision we would ever reach 10 feeds because of the prototype status of this project. At 70, we were thinking, okay, this will be our max, but unfortunately, it kept growing. Also, data would come. The guys from .spatial, which is an open source project providing a library to work with geospatial data, create queries and things like that, they decided to use MyGet as their means of storing their CI packages. So they started pushing packages. They create their feed. 1 week later, they were at 1,300 packages, 1 gigabyte of storage, and we were like, fuck. So
then blows your wheel.
So we decided to go and refactor and make it a little bit more stable than just accessing table storage directly. We decided on, let's use all the things we tell our customers, and let's focus on best practices, let's build services, let's use repositories, let's get solid and dry and things like that. Let's run on 2 instances, not just 1, because we were just running on 1. If something in the data center would fail, we would fail entirely, so we decided to go for 2 and have some redundancy in there. And we started. Someone on Twitter, and I even think it was Yves, thinking back, he said, I would pay for this kind of service. I don't think you pay right now.
That's because you did.
So we decided, well, maybe there may be a business model in this thing, and we started working on the public side, make sure that we have a business model in place. We added some billing and things like that. We saw our volumes kept going up, so more feeds, more packages, more storage being used, and we saw our users were both in the EU and the United States. So here's what we decided on architecture. Let's build the website like this. First of all, EU West will be our main facility, where we have a web role, where we have storage, blobs and tables, and where we use Windows Azure ACS to do everything. Apart from that, since we had users in North America as well, or in America in general, we also added a web role in the US, so just one in Europe, one in the US, and we put Traffic Manager on top of that. If you don't know Traffic Manager, don't worry, it's not in the new portal, unfortunately, yet, but it's a service of basically managing DNS failover. If one data center goes down, the DNS will point to the other one. You can assign it a geographical optimization, so if you have users coming from the US, they will be directed to the North Central US data center there. Perfect architecture, very stable, really very stable. We were actually, looking back, I'm really surprised that we managed to have awesome uptimes with just one web role in every data center, really. And then next to that, we were using the Windows Azure CDN to store packages, mainly because we saw the bulk workload of our website was people downloading packages. Okay, there was the package management, people were pushing packages, but the main workload was in downloading packages. And to reduce latency there, we decided, let's use the CDN, let's move all packages there as well, and users download from the CDN directly. So that's pretty awesome. Data centers near our users, one in Europe, one in US, CDN to do everything related to packages. Storage was centralized, so all storage was in the EU, even for the server running in the US. And we were using DNS failover in case one of the data centers went down or one of the machines went down. Since we only had one machine in every data center, if that machine went down, it would fail over to the other one. What we didn't know was, well, this data centers nearby our users or not. Actually, we didn't know. We saw users coming in from the US, but maybe it was all European people working for an American company using a proxy out there, or I don't know. We used the North Central US data center, but is that close to all our US-based customers? Yes or no? We didn't really know because we didn't have the actual location of them. Centralized storage, not such a good idea. Speed of light, I think Panos would really love if his car went at speed of light, but it's not that fast actually. If you have your storage in Europe, and your website does 5 calls over the Atlantic through HTTP with retries and things like that, some requests would take a couple of seconds before they were executed. So not that perfect architecture. The CDN, since we are recording, I will say the CDN is an awesome idea. But we had some issues with it. And I think other people will also say that in this room and in other rooms as well. Also, the DNS failover worked. We actually tested it, turn off one machine, see it fail over. Unfortunately, not every ISP out there is following the DNS timeouts and time to lives. So it could be that we did fail over to the other data center, but not every ISP out there was respecting this failover and still pointing to the one machine that was down. So not that ideal.
Telnet.
Telnet, yes. Yeah. But anyway, we persisted and we added some caching in the US. We made our setup a little different. We still kept one server in the US and 2 servers in the EU. But still, we saw speed of light was messing with us. Synchronizing data even to the cache in the US was horrible. It was really horrible. The CDN still was a great idea, but still. And what we also saw, we were running on 3 small instances, but if you would take the load of those machines, only 60% of one machine was actually being used, which means almost 2.5 machines were wasted, both in costs and in resources, so not ideal. We also pivoted. We had this marvelous idea. We started with a business model, and you have to revise your business model every couple of times. And we saw that, yes, we had our public packages where any user could just swipe their credit card and make use of the service. But back then, that was not really where the money was. So we decided, well, let's also support enterprise customers. And we started building multi-tenant architecture, basically, where every tenant would have their own domain name with their own instance of MyGet, which was just based on the DNS name. And it resulted in a very complex architecture because of the multiple tenants, because of the multiple logins for all those tenants, because of caches for every tenant and things like that. So it became really complex, and we decided, well, let's not keep investing in this architecture. Let's see if we can move to something else. And that's where our second architecture comes in. I think we did 1 year approximately on the first one. This one is also there for a couple of months now, I think 7 months. And we started looking at our workloads. We basically saw 3 workloads that we had. One was management of feeds, packages, users, things like that. Everything you do on the website, which is management of your system, basically. We were thinking about it, and it doesn't really matter where this is. So we decided, what if we do all of this in Europe? Even for US customers, if a page load takes 1 second to load the list of users, who cares? It's not something that customers would be doing day in, day out. They would do it maybe once a week or even once a month. So it's not a very important workload in terms of latency and speed and so on. What did matter was downloading packages. People were consuming feeds, their build servers were consuming feeds, so we still wanted to make sure that downloading of packages was really fast. It doesn't really matter where, but we decided, well, if there's a tenant coming from the US, let's just put the storage in the US and have him download the packages from the US. So that's what we did there. We also have builds, and builds, who cares where those builds are run? It's just a machine sitting somewhere, downloading code, creating a build and pushing it to the feed. And then you get back into the downloading packages workload. So it's not really important where the builds are located. So this is our next architecture. In EU West, we decided to go with 2 small instances, by the way, still today, 2 small instances. We have our storage, our main storage account, in which you will find all details about tenants, and some storage queues which do something like Yves just showed us, the event-driven architecture in which we store events and commands which will be processed afterwards. Then we do have multiple data centers in which the entire application has been configured. So we have a DNS name in almost every Windows Azure data center. We have our SSL certificates deployed in there, basically just to make sure that whenever something seriously goes wrong in here, we can simply deploy our latest release to one of the other data centers in a couple of minutes and have it running there and still have the DNS failover from Traffic Manager. Until now, we didn't have to do this, so let's hope it stays that way. But we did want to have this fail-safe in case something serious happens, where we can simply move to one of the other data centers. Then we have, in EU West, 1 storage account per tenant. So every enterprise tenant has their own storage account containing their feeds, their users, their packages, and so on. Like I said, we also have some storage accounts out there. If we have a customer sitting in the US, we just create a storage account in the US. No worries there. All the processing still happens here, and yes, we have some latency there, but it's mainly in the management workloads and not in the downloading of packages workloads, which is the most important for our customers. Then in EU North, we store backups. So we have daily backups of all storage accounts. We store them in EU North. In case something serious happens, we can restore from a backup in one of the other data centers. And then our builds, well, they run in EU West, and those are just a couple of VMs doing all the builds and publishing packages wherever they are required. Our first architecture was scaled across the globe, so we had multiple data centers, but it was slow. We had synchronization issues, And we saw, well, everything we were doing was synchronous code, and combine that with latency and speed of light issues, it's a terrible mess to work with. So in our second architecture, we decided to go with some sort of an event-driven architecture. Why do I say some sort of? Because there's different flavors, and we decided to just go with events and handlers, not all the how do you store your aggregates and things like that. Main reason for doing that, or for not doing that, is we already had a lot of code, we had a lot of repositories, and the refactoring process is something that takes a long time, so we didn't want to go full-fledged event-driven architecture yet. We wanted to gradually move everything into this new model. We do have some ground rules for new development, which is if it can be done in one write operation, do it immediately. Which means we are not using an event-driven architecture, for example, when the user logs in and we want to store the last login time. That's just one write, just do it. If not, if we have multiple writes in one transaction, throw it in a command on a queue somewhere, have a handler process that command, and have the handler trigger a new event whenever it's finished with its work. That's basically the main development ground rule we have. The thing is, if you have a login, for example, well, those are two operations, but it's kind of an edge case. We read the profile and we want to store the fact that the user has logged in by changing the last login date. We simply do it, but we also trigger an event so that whenever someone needs this information, that a user logged in, for example, and wants to store it somewhere, we also can have handlers processing these events. But it's a pretty synchronous thing because it's just one operation, in fact. Another one is change feed owner. When you have one feed and you have two users and the feed is owned by user 1 and you want to transfer ownership to user 2, that's a lot of stuff to do. We have to read two user profiles, we have to read the current access rights for both users. We have to change the access rights, we have to push new privileges to symbolsource.org, which is where the symbol server lives. It's not something we built, it's an external service we use. So that's a lot of work to do. And what we do is our UI will trigger one command, which is the change feed owner command. We have a handler for that, picking up this command, doing everything in there. And once it's finished, it will trigger a feed owner changed event, which others can use to have some logic in there as well. Good question may be, is this thing transactional? No, it's not. Just like in Evestock, this thing is checking basically every edge case that's possible. Did we already assign the new user access rights to this user or not? Based on that, we can simply, whenever something fails here, we can retry, and the next time perhaps it will succeed. We retry a couple of times, and if it really doesn't succeed after a couple of times, we just put it on a dead letter queue and we inspect and see what's in there and what we can do about it. The game about going to an event-driven architecture, well, quite a lot. We now run on 2 instances, which is mostly for redundancy. We used to run on 3 instances, but now we run on 2 just because we want to have 2 instances in case one of those machines fails. The average CPU usage of those 2 servers is 20%, spread across those 2 servers. So in theory, I think regarding CPU, we could even scale down to extra smalls. No issue.
Yeah, bandwidth, you'll have problem with bandwidth.
But we'll have problem with bandwidth we need, and we also have some in-memory cache in those instances, so we need the memory in there. So that's why we run on small. But in theory, for CPU, we could just go to 1 CPU. Another game with this event-driven is that it's a way easier programming model. Xavier had the idea of building an activity stream in which we could see this user created that package, this user created those access rights for this user, this package was deleted, things like that. How would you go and build that in a traditional architecture? You would have to basically find everywhere where you do something like those things, inject code in there, writing something to an activity log. You don't want this. What we do is we simply throw a new event whenever something happens, like a package has been added. We have one handler catching a ton of those events, and that handler will write data into the activity log. This feature, the activity log, is quite big if you see it in the websites, but I think it took only a couple of hours to actually build it, including all the UI work there. So it's really easy to extend and build new features on top of this. Storage, why no relational database in this entire application? Well, I already told you we were doing NoSQL back then. And, well, we kind of got used to it, and we actually really like table storage for doing everything, especially in combination with the event-driven architecture, especially in combination with storing data in duplicates depending on how you will query it. So it's once you have the infrastructure, it's really fun to work with. Another question there may be, well, if you only have the partition key as a real index, how do you store things like feeds and packages, or packages in a feed? A package is owned by a user. It is on some feed, it has an ID, and it has a version. So that's 4 properties. How do you store this in an efficient way for querying? Well, we decided, well, the table name is also something we can use to index. So actually, I think we have, I don't know, if you go look at the homepage, how many feeds we have online, that amount is the number of tables we have. We have a table per feed. If we want to query packages for one feed, we simply know it's in that table. Then we use the partition key, is the ID of the package, which is very efficient because if we want to get all versions of one package, we can simply query the package ID, and we will get all of them. And then for the row key, we have the version, so we can do ordering there, we can do sorting, and we can fetch a specific package from one partition in a table, because every package is a partition in there. We also found out that reading a lot of rows is quite slow. Reading 500 rows from table storage is slow as hell. Reading 1,000 or more is even slower because you typically have to do multiple requests there. And really, literally many seconds to query all this data. So that's why we decided to cache some tables on block storage. We also cache in memory, but data that is not frequently used and that can be cached in some sort of serialized format, we cache those on block storage. Why? Because it's small. Serializing 1,000 entities is relatively small in JSON, for example. So we store it in on a blob. If we need that data, we just load that one blob. It's just one HTTP request containing one file, which is quite fast. And we search in memory through these 1,000 packages, for example. Not saying this is the best architecture, but it really works well, and it's quite fast to query in this fashion. Okay, ACS, another interesting one. ACS. Well, imagine managing something like this. You have multiple applications which have a dev, which have a test, which have acceptance, which have production, and things like that. And you have multiple identity providers. Windows Live, Google, Facebook, maybe Twitter, maybe some ADFS for one enterprise customer, maybe an ADFS for another enterprise customer. So if you combine all that, you get something like this, like a giant spaghetti. Now to do something about that spaghetti, you can use Windows Azure Access Control. The main idea there is our application only knows about one source of users and identities and authorization rules, which is ACS. In ACS, we can plug in different identity providers, we can plug in different relying parties. So every tenant on their own domain name is a different relying party in ACS. And we can create some rules giving our application the claims from, well, if a user comes from this URL, uses this identity provider, we want to have this information. That's basically what we do in ACS. So it's kind of a service bus linking together all these identity providers and all these relying parties, these applications making use of those identities. So what does it look like? Well, we have a couple of environments. We have our local development, local host environment, and that thing is known in Access Control Service. Since we do not want to have all the identity providers in there, we just have Google, Windows Live, and I think Facebook configured in development. Why? We want to be able to test with multiple identities, but we don't need them all to run our development stuff. Then we have staging, and in staging, we have another configuration. Staging is a different application for ACS, and on staging we have them all. We have all identity providers, but not the ones we maybe host on our local development machine. And then we have production, but production is kind of different because production is multiple tenants. So every enterprise customer has their own domain name, and for ACS, because the domain name is different, it's a different application, even though it's hosted by the same two virtual machines in there. But for ACS, that's a different application, and using that technique, ACS can decide, well, for that domain name, we should go to that ADFS server. For that domain name, we want to show GitHub as a login provider. For that domain name, we want Windows Live ID and Facebook, for example. So it's really easy to use Windows Azure Access Control Service for this, instead of building it yourself into your application. Another one, no more user registration. That was the main reason why we went with ACS, and that still is one of the big reasons. Users typically have some identity that allows federation, like Facebook, like Google, like Windows Live ID, like whatever in there. The fun thing is we do support all these things, but we do not have to configure them all in our code. We just configure ACS, our code knows about ACS, and ACS is the one true source of identity. On a side note, in Windows Azure ACS, you get Windows Live ID, you get Yahoo, you get Google, and you get Facebook. But you don't get GitHub, you don't get Bitbucket, you don't get many of the others like LinkedIn, for example. And we've been building those, and we've included them in MyGet, so you can log in through a GitHub account, for example, on MyGet. And a couple of weeks ago, we decided to pull all of that out into a separate project. So if you want to have those other social identity providers, small commercial break, if you go to socialsts.com in the meanwhile, you can just use that and add those identity providers into your ACS configuration as well. So socialsts.com is the one where you can go. There's also no difference between environments. If we have an identity that is known in Google, and we log in into our development machine, or we log on to production or into staging, that same user account is known across all those different locations. Except for the fact that maybe because I'm using a domain name for production, ACS will add a different claim saying that this user can be an administrator on development, but maybe not on production, something like that. Our application will just get all those claims from ACS and doesn't have to care about anything else in there. Yes?
Can a user log in with Google and then the next time uses Facebook? Do you know who is who?
We have added support for that as well. So if you want to have multiple social identities linked to the same accounts, we have support for that. So basically in our data structure, we have a user profile, and through a user profile, we have multiple linked social identities.
But you have to do it yourself.
But yes, you have to go into the website and you have to link those yourself. So if you go to the website, you log in into Windows using Windows Live ID, you go to the profile page and you say, I want to add my GitHub account as well. Okay. Then we will make the association, but it isn't supported by anything in the platform.
The default MVC template now, if you create a website, an internet website, it has that notion of the user profiles and the linked identities in there, so you can just use it directly. Okay. But you have to modify the code, but the structure is already there, so you can.
There's also no real difference between tenants. Every tenant is on on the same two machines in Windows Azure. And based on the audience for the tenant, based on the domain name, in fact, ACS will decide which claims are being sent, which identity provider is supported, and so on. Our application just simply gets all the claims coming from ACS, and we don't even care what the domain name was. We just receive whatever comes from ACS. It's really fun to work with because ACS really does a very good job in separating all these things. Then we had some tough times or learning moments. We had a giant downtime on July 2nd last year, and there were some symptoms. What we saw was some users complaining about downtime on Twitter. We saw some users sending emails about downtime to our email accounts, but we did not get SMS alerts from our monitoring provider. Until half an hour after the first citing of downtime on Twitter and in our email, we received messages saying site up, site down, site up, site down, like almost 30 seconds in between every message. By the way, you can see in there, in that monitoring diagram, that we had like up, down, and so on. There was also no sign of any issues in the management portal of Windows Azure. So we went in there and both instances were just saying running. Nothing very wrong there. Everything seemed normal except for the fact that we received the SMS messages after half an hour and users were complaining. But what's the cause? This was right after we released our second architecture in which we deployed all the multi-tenancy stuff. It was right after we enabled storage analytics, back then a very new feature on storage. And Elma was showing some storage throttling issues. So we went in with Elma to the web server, and after a long wait, we got back the result from Elma, and was saying there are exceptions based on throttling on storage. So we were like, what? We are being throttled on storage? But why? Was it because of our multi-tenant architecture we deployed? Or was it Microsoft who forgot to do something about not including storage analytics in all the storage throttling thingies? It might be a possibility. You always blame someone else. Another thing we saw was about 16,000 messages and events in our command queue. So a lot of stuff that was not really being processed. Well, we discovered after a long investigation, really debugging and finding whatever happened, that one line of code, actually one line of code, grounded our entire website. Get hash codes on a package object. This comes from MSDN, and we deployed get hash codes, I don't know, maybe back then in our proof of concept periods, but we implemented get hash code on the package object. And we learned the very hard way that not every hash code you get from a string, well, there may be multiple hash codes being the same, even if the string is not the same. So we had that in there. Now, unfortunately, get hash code is being used in the storage SDK for Windows Azure to determine if an object has been changed or not. And because of this mismatch, two objects having the same hash codes, it went like, okay, I already have this object, I cannot update it again, so unhandled exception. Good question now, maybe, don't you handle unhandled exceptions? Don't you just catch them? Yes, we do. Back then we catched every exception that occurred in our processing, and we just started retrying. Every exception that happened, we retried for a couple of times. If after a while it didn't work, we would put it on the dead letter queue. Problem is, if you have 16,000 messages in your queue because of this error, and all those 16,000 messages trigger retries and new exceptions, and again a retry, and again a retry, and again a retry, it causes storage throttling. Because storage throttling is there, new exception gets created, and we retry again. Which means our website, just browsing the website, reading data, also causes throttling on storage. And because of all this throttling, we were just starving worker threads on IIS. And basically, the website was behaving correctly, even though it was running at probably 120% of CPU usage. So it was literally, it was almost a meltdown of the Azure data center. So lessons learned there, one simple bug, like a get hash code, can grind an entire application to halt. So be careful, test your code, test your code. Only retry transient errors. So if you have an error because the storage could not be connected, or there's a network failure in connecting to SQL Azure, retry those things, but do not retry every exception. Don't. We did it back then and it caused some pain. Our monitoring basically sucked because we only got messages after half an hour, and still that monitoring was not sufficient to give us enough information about what was happening. And also our code sucked, and yes, because it was just a blog post we started with, a simple proof of concept. That code was still in there. By now, most of that code should be out, and I think almost all code is out. But still, one line of code can cause an entire application to fail. Quite recently, we had another huge downtime on February 23rd. Who's running on Windows Azure? Who's using storage? Who's using HTTPS to connect to storage? You were in the same boat. Symptoms, well, everything was down.
I'll tell you.
Okay, yeah. Everything was down. The website was down, storage was down. We saw a lot of tweets about Windows Azure is down on Twitter. We went to the management portal and we couldn't see anything because the management portal was down. And well, yes, we decided this is not our fault. This is Windows Azure having a global outage because of an expired SSL certificate. When you connect to storage, you can decide if you want to connect to storage using HTTP or using HTTPS. In our case, we used HTTPS, which is the recommended way of working because that's some security at the transport level. But because of that, and because of the fact that this SSL cert was expired, we had a major failure there, and we were not the only ones. And we took some lessons there. Should we move storage connections to HTTP instead of HTTPS? Still debating about it, but we will probably not move this for two reasons. We want to have this additional transport layer security there, and I don't think Microsoft is going to make this mistake again. So that's the two reasons why we probably will not switch to HTTP. We did learn that Windows Azure going down globally impacts us quite a lot because we're unavailable. However, failover to another solution like having Amazon or having a local hoster running a copy of this website would cost enormously. And currently the trade-off between costs, efforts, and the earnings we make on this, we are not considering on having a duplicate setup on a different cloud or a different hoster. What we will do, and what we're working on now, is instead of only having the backups in Europe North, we will also have backups on another cloud. So that's one of the things we want to do. Make sure that even if something really, really goes wrong there, we still have the backups available and we can restore something else, maybe. Maybe in a very, very lightweight fashion of our current website, but in case of a serious downtime, we may want to use it for other scenarios. One more learning moment, new features. A couple of months ago, I think we released the notion of retention policies. So if you do continuous integration and you push packages to MyGet, you can quickly get a lot of packages on your feed. And we're seeing a lot of users complaining, well, every day I have to go into the website and delete every package except the latest 10 that were pushed yesterday. So we decided, let's build retention policies for our heavier users and have a way of automatically removing all those packages that are not being used from their feeds. We introduced it, we blogged about it, we tweeted about it, and in the evening we saw emails and tweets. I pushed the package, but I'm not seeing it appear. So I was like, okay, yeah, that's probably our cache not being invalidated and repopulated, but why? So I went to the Azure portal, and I saw nothing was really wrong. Everything was behaving normally, except for the fact that if you push the package was not appearing, and some other caching-related issues. I was thinking, okay, if it's not that, it should be the queue. So I opened my Storage Explorer, went into the queue and saw 3-something million messages in there. Why? Because a lot of users apparently enabled the retention policies. They triggered a lot of deletes, which triggered a lot of activity stream additions because of the events being triggered, which triggered a lot of events, really a lot of events. And because of that, stuff like updating our caches was not being executed yet because it was way down the queue. So that was the main issue there. How did we solve this? We scaled out. In this case, we could just scale out and have multiple processes working on this queue. And we managed to, well, in 5 minutes, the entire queue was processed, but still it was quite an interesting one. Lessons learned there, like Yves was suggesting, multiple queues. We will be moving to multiple queues. Another thing we will be doing is feature toggling. So whenever we release something where we suspect the load may be quite huge, and we actually already did this one on build services, we decided to work with a feature toggle. So only enable it for a couple of users, see what they do with it, enable it for some more users, see what they do with it, and then enable it for everyone. So that's what we did there. How did we do it? Some fancy framework? No, we just added a feature toggle field in the user profile, and whenever the user had that feature enabled, it would show up in the portal. Some bonus tips, not really on Windows Azure, but something if you have an idea that you want to work on. Panos already told you, Eve already told you, but measure everything. Test your assumptions. Everything you do is based on assumptions. If you build this, we started building this and we thought no one will ever pay for this. People wanted to pay for it. Wrong assumption. Measure everything. A lot of the startup books, like the Lean Startup, for example, tell you measure everything, but how do you do this? What do you measure? What do you measure? How do you measure? You don't know. One thing you should do is don't build it yourself. Use Google Analytics, for example. We actually created the Google Analytics tracker package on NuGet, which is something we use in MyGet, but we decided, well, maybe other users can benefit from this, so we published this thing, and you can use it in your project as well. What we do is, whenever you trigger a feature, when you create a build, when you log in, when you create a user without going through Windows Live ID, but just creating a username and password, we track everything there. And if you do that, you get something like this. You get your standard analytics, but under events, you can see this page. We see our features, and we see the names of our features, and the amount of times every feature has been used in the past few weeks. This one was quite recently. We discovered that during the last few weeks, a lot of users apparently were using the traditional login. Not using Windows Live ID, not using Facebook, not using Google. They were using their username and passwords. So apparently, while we didn't have a real registration page, but the users were still using username and password, we did have to build something around traditional logins with username and password. So we created a registration page, and by now, I didn't include a screenshot, but we can see that building that feature actually had some success, because it's showing up in the top 10 of all the features being used. So people were actually asking for username and password registration. Managers probably, or build servers, or build server accounts being used and things like that. But we didn't know up front, we didn't ever assume anyone would want their username and password created, yet this thing revealed that we should provide a feature like this. Second one, trigger builds. This one it's always on the second place, so it's really in our top 10 of most used features. We should keep investing in this. Absolutely, that's very clear from the statistics. Feed discovery. That's something we released 2 weeks ago. And we were thinking, well, we will probably have one user using it and nobody else will care. It's in the top 3 of the last month, after 2 weeks. So we should build on this and do something with it, even though our assumption was that we will get 0 reactions and 0 information on users making use of this. So using this really showed us that while we thought it was not important, people do find it important. And, well, we had a technical fear. We introduced a month ago a feature called download feed as zip, in which you could just click a button and download all your packages in a zip file. And we were thinking, okay, if we deploy this, everyone will start making backups of their feeds, and we will just grind our servers with zipping files into a zip file. Apparently, it's the least used feature ever. So it wasn't really worth investing time in building. And the fear that we had on the technical side wasn't really funded because no one is using it anyway. So.
I can create subscripts to help you.
No, thank you.
We know how to DDoS you now, you know that, right? You said it publicly.
So, in conclusion, there's a lot of things you will learn along the way. And I've been saying Panos because it's not yet in production. You will see a massive amount of wrong assumptions you've been making into both the architecture, both the business model, and things like that. But if you do build an application on Azure, think about the architecture. Don't think too much about the architecture because it will fail anyway. It will fail and you will have to change it. Think about using ACS for all your identity stuff. Even if you only have one identity provider and 1 or 2 applications, it may still be worth using in the long run. And if you have the infrastructure ready, it will be worth it in the long run, and it's not a big investment in starting to use it. All the tough times, use those as your main learning moments. Those are the learning moments mainly about architecture and about legal and all those implications as well. And other learning moments are your measurements. Have Google Analytics or something else and measure everything and make sure you learn about those things. So, thank you.
How many integrations with ADFS do you have?
We have, I think, 4 or 5 currently.
And when you add them, do you need some manual configuration or configuration Azure? Or?
If we have a new enterprise customer, everything is currently manual setup. Another one of those things, if you don't think you will do it that often, just do it manually. So that one is still a manual process. And right now we still provision ACS manually for new ADFS servers. On the other hand, there's a pretty good management API for ACS, so if you wanted to automate it, it would be no issue of automating it.
And how do you charge your customers, especially for builds? I can imagine that queuing a new build can consume some CPU.
That's true. Builds can consume a lot of CPU. What we currently have, the feature is in beta. And if we, well, you will see some features are in beta for 1 or 2 weeks. Some are in beta for half a year. The main reason is not the technical side, but we keep it in beta to gather as many measurements as we can to know how we can build this. Because, well, we saw a lot of users making use of builds, and they had a build.bat. And at the end of their build, they had a pause statement, and the build server would just wait forever because there's no input there. So we decided to add stuff like we monitor the process, and if we don't see the process doing anything for a given amount of time, we just kill the build, basically. But what we do want to know is how are users making use of this service? Are they all creating builds of, say, 1 class library with 2 classes? Or are they really building a massive project with a number of projects in there and a lot of compilation work and unit testing and so on? So we're still in the process of measuring that and making sure that we have a business model that's both interesting to the user of the service and to us as well.
Welcome to the customization from customer provided stuff. So.
Yes. So it's trying to learn about how users make use of this feature and how we can react to that on the billing side.
Yeah, if you start accepting stuff from customers for customization, you always treat it as the worst thing you can run on your own infrastructure. So that's the only way you can be safe. So you always have to treat it as the most untrusted, most shitty, most bad thing that you can run on your infrastructure. There's really no other way to be protected. They do this thing, they monitor the process. In Volkswagen, I do code analysis basically. I'm looking at the namespace references and all those things, and I'm blocking spawning new threads and stuff like that within the customization because it's not supposed to do that. But yeah, it costs time.
Yes.
You were saying that you were creating separate storage accounts for each customer. What's the reason behind that?
The reason for having separate storage accounts is isolation. We really want to have isolation between every customer. We don't want to, if we have a bug where some user sees a feed of a competitor, we don't want to risk it. So that's why we chose for different storage accounts. Also because we use the private feed per table. So every feed is a single table. If you have a dev feed in your account and you have a dev feed in your account, well, only one of them can have that same table, unless we add the tenant information to the table name as well. Then again, creating a storage account is just something, it's a logical thing. It's not something where you suffer from performance or additional billing or something like that. It's just a separation.
How did you remove the limit? You just conducted support? 20.
Okay, the limit on storage accounts, by default the limit currently is 20 accounts, and we just contacted support and they ask you why do you want to do this, and you say this is my architecture, and they just up the limit.